With great data comes even greater access latency. Welcome to the Trino Community Broadcast, where we transform your latency woes into fast insights. The Trino Community Broadcast is a show where we cover events and happenings with open source Trino community and show off really cool things about Trino, including Druid. So this week we are going to be, the title of the show is Make Data Fluid with Druid. There's an implication there that we're dealing with some really fast real-time stuff. We always say the word fast whenever we're talking about database systems, and so we're going to really talk about what fast means in different contexts today, because obviously Trino's fast, but Druid is faster. And so we'll be handing that off to some of our guests here today. So in fact, why don't I do a quick round of introductions to all of our guests. Let me first start out with Rachel. Rachel, I'm really going to butcher your last name. Could you just, Pedrushi? Is that right?
Close. It's usually pronounced Rachel. How do you pronounce your surname? Is typically how my last name is pronounced. So I'm Rachel Pedruski.
Perfect. And she's coming to us from Imply, and one of the big representatives of the Druid community. And then we also have Parth and Samarth from Netflix. Thank you very much for joining, gentlemen. And of course, my typical partner in crime, Manfred.
Yeah, I can't hide.
So basically, let me pull up real fast. We're going to do a quick message from the sponsors, which is Starburst. I'm going to pull up a new book that just came out today. Let me see if I can find it. Trino. Trino.
You can just go trino.io and go to the blog, and there's my last post.
Yeah, that's also true. Let's do that. That's the easiest path to get to it. Trino, the definitive guide.
Yes, it is out and ready to go. And it wasn't just a simple string replacement job, just like it wasn't easy to change the project name from Presto to Trino. The book also wasn't easy to change, but it was definitely worth it. The Trino book is out now. Trino, the definitive guide, is the updated version of the book we finished last year, called Presto, the definitive guide. Trino, the definitive guide, is updated to the latest release 354. So it's literally like hot off the press.
Nice.
Bunch of content has also been updated. All the erratas were changed. And me and Matt and Martin went through and checked in with Dane and David and the founders of the project as well. Got our sort of forward updated. Updated what's happening to the project in the history, all those kind of things. And of course, it has still information in it that you can't find in any other place, like with more details about the web UI, practical use cases, and so on. So, and the awesome news that we have from Starburst is that, again, we're making this book available for free. So there is no sort of barrier to entry to Trino as such. Just go to the Starburst website, linked from the blog post, and get your free copy of the PDF and learn more from that.
Yeah, and we're gonna add that URL into the show notes as well. It's typically we have these running on the bottom anyway. So if you go to the show notes right here, if you want to download the definitive guide for O'Reilly, the link is right there at the bottom of each of the show notes. You can also
find it on that blog post on the Trino website and on the page on the Trino website about the book. So
definitely
can't really lose it. And of course, all the authors, including myself, but also Matt and Martin, are constantly on Slack. So if you want to find anything out about the book or have questions or let us know that it's terrible, that's also good. Just contact us on Slack.
Well, actually, I let you know that it was there was a couple things wrong with it on some of the errata. One in particular.
Yeah, I know, but I fixed those.
So there was, I guess, one where I think the chart, I can't remember what the chart actually was, but it was pointing.
The errors from the statements was wrong. Yeah. I know. I blame the O'Reilly image maker because.
Yeah, that was their fault. I totally agree.
Yeah, of course.
So one other thing we want to talk about that's coming up, if you go to starburst.io/Trino Summit 2021, will also be in the show note. we have a Trino Summit coming up in September. So we are just now pulling together some of the topics that the folks in the community really want to hear about. We did a survey not too long ago trying to get an idea of what everybody's interested in. So now we have opened up the registration page and we will be going live in 138 days, 21 hours, 53 minutes, and 48 seconds. So so just go to that page. It's on will be included on the show notes, and then register for general admission. That's all it takes. There was some weird issue that happened with the registration for a sec that I think is fixed now. It said that there's an email that's supposed to be sent and it never sends. I've since fixed that issue, but I want to just make that clear to anybody who is registering. If there is any issue, just reach out to me on Trino Slack, or you can even, if you're not on the Slack channel, I'm on at Bits on Data Dev and Twitter. Hopefully you're on one of those two things. And so that's basically it. Trino Summit's going to be, I think, the primary thing that people are interested in, it's around data lakes and then just specific technologies. We might even be having some of our guests here today joining us as well, possibly. We haven't confirmed anything, so I don't want to start making promises that we can't back up. But
also until September, as you saw from the ticker there, 138 days. I think that gives us chance for at least, let's say, 5 or so releases or a bit more. So plenty of opportunity to send more pull requests and improve the project even more. So if you think the Druid connector needs some more work, go send us those pull requests and work with us and
absolutely
everyone else here on the call to get it even more improved.
Speaking of the release, so I tried clicking on this link this morning and it doesn't go anywhere. So what's going on with the release, Manfred?
What link are you looking at?
I'm on the link that I set up that anticipated 356 being done today.
Well, you're too eager. In the other notes, I sent you the release notes pull request. So literally the release is I don't know, minutes or days away. We are assembling the release notes. Code is pretty much frozen. And maybe by the time we listen to this or watch this tomorrow or the day after, it will be live. So 356 is coming out, and there is a bunch of really cool things on the way again. I think one of the features that people will be most impressed with, or have a good opportunity to scratch the head, is the match recognize function. So this is a new SQL statement that's going to be supported, and it allows you to query, write a query where as part of the query, multiple records are taken into account, and then do sort of training analysis within it, seeing if records have a behavior of the price range within and stuff like that. Pretty complex to understand, but we have a very explicit and long documentation about it. You will have to check it out, but definitely one of the very new SQL standards, from 2016 or even newer. So
when I see match,
cool.
is it supposed to be is it like a kind of an Elasticsearch type functionality where it's doing a search type thing, or is it more
No, it sort of goes through a record set, and for each a number of records, it can sort of match against, say for example, the price went up and was above a certain
okay,
and find all the customers where in that time it went over and stuff. It's pretty complex, but the statement itself is pretty complex, but it gets really close to where you feel like you're really working with a full-on programming language, where you actually have to scratch your head a bit about what you're writing. But it's pretty cool. So I very much recommend checking out the documentation for that.
Nice.
Another small hack is the SoundX function came out, which is just a function to sort of convert an English word to what it would sound like. So that's kind of funny. Has surprisingly many use cases actually, and it was a pretty small PR to get it in. So that's cool. Often requested feature, we have a property now that allows you to limit the planning time. Some queries can take a long time planning, and that obviously introduces a bit of a load on the coordinator, since all the planning happens on the coordinator. And you can now set a limit, right? The default limit is, I think, pretty high. but and is most of the time sufficient.
Hmm.
But if you end up with problems where, like, say for example, you're playing around with recursive queries, for example, which we do support, then setting that can help. And also as part of that, obviously, since there is now a limit, the cancel behavior needed to change and be improved as well. So we made sure that there's better cleanup, and we don't have like things laying around when when a query is sort of the processing canceled during planning.
Oh, that's pretty cool.
It's very, very practical. Lots of our customers wanted to have that sort of thing.
Yeah.
A whole bunch of performance improvements came in, literally around push down and various like in statements, other various predicates with values and joins and stuff. You'll see those in the release notes. Also related to that, related to materialized views, there's much improved view support for materialized views with like a table in the systems table and various improvements around that.
Is this Coral, the Coral upgrade fix? Or is that something totally
no,
different?
it's like, yeah, it's related to Coral, but it's in general, it's also materialized views to be treated sort of like tables when they are materialized in the underlying system and stuff like that.
Gotcha.
JDBC driver, we recently added a lot of support for OAuth and single sign-on browser-based SSO. And of course, that all works via token. So now the JDBC driver has a caching mechanism in place so that the credential token is basically cached in memory. So that makes it much easier and nicer for users that use any sort of application that uses the JDBC driver, so they don't have to reconnect and re-authenticate with the OAuth system as often. The BigQuery connector got create and drop schema added, which is pretty cool. So there's always something going on in that connector as well, which is pretty awesome.
I hadn't seen it for a while, but crops up every once in a while.
Yeah, straight from Google, and it's good.
Good.
Hive connector has improvements around little small performance improvements and tweaks around Parquet, Org, and the Azure ADL support. So for Azure ADL, there's a support for a proxy, like a caching proxy between the endpoints and the Hive metastore. Iceberg, again, a couple of smaller figures, specifically show tables now works even if the table was created elsewhere, like in some other tools like Spark and so on. There was a break around that.
We covered that like two episodes ago. When I was doing the demo, we had to do that weird little tweak in the meta store.
Yeah, exactly, and that's now fixed and is gonna be in that release for sure. So
nice,
like that. Kafka has SSL support now, so that's for the authentication to the nodes. A whole bunch of connectors, like all the ones that are like typical JDBC connectors, like SQL Server, Oracle, Postgres, MySQL. They have improvements on the metadata caching. And then there were a bunch of changes on the SPI, mostly around this whole increased stuff for the materialized views.
Awesome.
So additional like methods and signatures in the SPI, which obviously doesn't impact you if you don't use the stuff that wasn't there before. So it's cool.
Very cool.
It's nothing breaking. So yeah, another good release. I definitely encourage all the SQL nerds to check it out and play around with match recognize, or at least, look at the documentation and scratch the head a little bit.
Nice.
When I was reviewing that with the developer to make it consumable, I definitely had to scratch my head. I can tell you that.
Very cool. Anything else you wanted to cover on this upcoming release? Anything else breaking, or are we still adding? You said it's frozen, right? So we're just basically waiting on all.
It's not frozen, but it's in that like where we're writing the release notes, and like it's pretty much imminent. So nothing big will be merged. That's for sure.
That hasn't been merged already. Cool.
Yeah.
Awesome. Well,
so now I want to learn about Druid.
Yeah, let's learn about Druid. I'm gonna first show off our Ali's little animation here that for Druid, and while we're looking at that, I am going to actually do something I have not done on the show before, which is live adjustment of our OBS scene here. Let me just do this real quick so that we can focus on our next speaker, Rachel, and so we can see her floating head. I clicked on the wrong thing. Give me
For those that are listening on the podcast, by the way, while Brian does that, what Alison has created, she's created a little commander bun with a really crookedy sort of druid stick. I'm not sure what he's holding. I think this is his beard.
There's the cane.
What's the other thing in front of his face?
It's a beard.
Oh, it is a beard.
Yeah.
See, that's what I was asking. It's a beard. And then I'm guessing this is in Stonehenge, which is...
Yeah. Yeah, that was the idea. Like I know there's a lot of basically, like, I don't know. I'm not going to try to pretend like I know anything about druids other than that they're a big player in D&D as well as Diablo. So why don't we let the experts start telling us about some information about druid, and I think you talk a little bit about druids in general, right, Rachel?
Not really.
Come on.
Actually, this particular druid came from World of Warcraft. So that was the original authors of Druid.
Oh, okay. So this was a World of Warcraft reference then. This whole naming. Okay.
Right. As much as we would love to have like the Stonehenge Druid, and I like to use it as like, you know, the wizard or use your Druid magic or anything like that, but no, it's World of Warcraft.
Yeah, but in World of Warcraft, it's a character type for that magic, so you can totally still make that claim.
Yep.
All right. Excellent. I'll try. Anyway. Well, thanks for having me today. I'm super excited about this.
Yep. Thanks for coming on.
Yeah, Brian and I have been talking about the big data landscape, among other topics over the last few weeks, and trying to figure out, you know, what goes where, and, you know, where do you put this and where do you put that, and there seems to be able to have a constant conversation about it. We'll put it that way.
I mean, because like when I look at this, you know, modern real-time OLAP for database for data-driven applications, like, I mean, when you just see the word OLAP database, you're kind of thinking like, okay, so I mean, Trino does OLAP. It's not a database, so here are a couple differences, but like, you know, why would I need one versus the other, and what are the use cases? I think is something that's constantly confusing for engineers that are just breaking into this space, especially.
Yeah, and that's where I like to talk. So my presentation on what Druid is actually a history lesson, because I think putting it in the concept of where it belongs in the timeline of OLAP databases, because they've been around for a long time. So let's just hop into the Wayback Machine. Can you go into the next slide? Thank you for those who get the reference. And we're going to go way back to, oh, nope, that's too far. That is a Druid. Let's go. Keep going. Going. No, you're going back the wrong way. There you go. Yay, we're going to the 90s. Some people on this call remember the 90s. Next slide. And Al Gore, the internet. So it was a good thing. But this is what data warehousing architectures look like. So that next slide, thank you. This is when I got into the world of data warehousing back in the 90s. Yes, that does mean I'm that old. And I worked for a company called Red Brick, and I was a technical support engineer. So Red Brick was one of the first databases designed for data warehousing. Up until then, you tried to make Oracle work. Teradata is another option here. But this is what the architecture looked like, is that you had data from all your different data sources, you know, usually Oracle, sometimes Informix. And you had your analytics on the right-hand side, all the way over your users. What did they need to know? These were non-technical people. And so you would put these things into a data warehouse or a data mart, which is a subject-specific data warehouse. And that little blue box that says ETL seems very like easy and, you know, unobtrusive. It's just a little blue box, but actually this is the hard part. It's like actually taking all that data from the different data sources and massaging it into what at that point was a denormalized style schema called a star schema or a snowflake schema, and figuring out how do you get that data into that format. Gartner at the time said ETL would take about 18 to 24 months to do for an enterprise data warehouse, which is a pretty long time. I built a data warehouse at the turn of the century for Vail Resorts, and it took me 10 months personally to do 32 different data sources just to get it into a little data mart for marketing. So this is,
and that was the last time you had to touch it too, right, Rachel? Like, I think, you know, once you get it set, it should work forever, right?
Oh yeah, never. Yeah, of course. Like, it never breaks. Nothing ever changes. Oh, and you know what really never changes? customer requirements.
Oh,
they
yeah.
never changes their mind, especially after 18 to 24 months.
Yeah. So you
Never
just
say,
like,
oh yeah, it's fine.
you just get to drink on the job afterwards, right? So that's what I hear.
Well, in my case, I skied on the job, but yeah, because it was at Vail Resorts, so you know, I just went skiing every day.
There you go.
It's great.
Yeah,
right.
much healthier.
All right, let's go forward a little bit in time.
Okay.
You know, everybody's like, oh, this is ancient history, Rachel. We're gonna go to the 2000s. You know, back in my St. Jobs of Apple, you know, brought the mobile world to us, and that mobile world brought us a lot more data. And I remember at the time people going, well, there's no way we're ever going to get through all that data. So what's all the point of it? And and the whole process, that ETL process, and that whole idea of storing all that data became a tad overwhelming. And more than overwhelming, it became a lot expensive. So trying to figure out how to scale a single node Oracle database to hold all the data from all your mobile applications and your web properties just became overwhelming. So somebody came up with a great idea of Hadoop. But then we also have S3 and blob stores and other various data lakes, which I know is a concept that you guys are a tad familiar with.
We know a thing or two.
And then ETL got pushed out to then what we call ELT, which I don't know why in my slide doesn't have that as ELT, but is so very similar to where, you know, Trino fits and some of the other architectures of this time is like, take the data out of your data lake. Don't worry about how it looks when it goes into your data lake. Worry about how it comes out of your data lake. And I like to call this a schema on read versus a schema on write. So the previous architecture was schema on write. This is schema on read. But for the most part, you still have users. They still want stuff, and they're still going to change their minds a lot. All right, so let's go to now. It should really be an Apple Watch, shouldn't it? But I'm going to go ahead and go next.
Maybe Google Glass.
And what's great is, you know, companies like Netflix, who are here on the show with us, are, you know, some of the early adopters of these types of service expectations and how to provide analytics at the same rate that you provide your web applications or your mobile applications. So data-driven and data analytics applications require the same service expectations that you would for on your phone, right? Which you can't see because of my background, but yeah, like so. Analytics has moved into a new realm where it's not just enough to be able to take data and, you know, query it at some point and maybe at another point give users certain reports or let them change their minds. We need to have it interactive, adaptive, personalized, etc. So can you go to the next slide? And I have an obligatory Gartner quote because I can't do any type of presentation without an obligatory Gartner quote. Yeah.
That's how you know it's legit.
Blah blah blah. Yeah, that's how we know they're. So now we have a new set of challenges, right? So it's now big data plus because it's not only you have a ton of data, not only do you have these now distributed architectures, you now have the concept that the data has to be coming in real time, and people want to interact with it in real time, and a whole host of data pipeline tools have now become kind of the de facto standard. And that ETL world has now stretched, and it's instead of just being one time or ELT at the end or schema on read, schema on write, kind of schema all over the place. And you're using things like Flink or Spark Streaming or Kafka Streams, you know, you name the technology there, and you're constantly doing ETL, or what we call a data pipeline. And this type of architecture required a new type of database. And I like to call this architecture the data rivers because it kind of goes with the lake thing. People saying that data rivers doesn't sound fast enough. So it's like a class 5 data river where the data is just, I don't know how to make that work.
You mean like heavy white water with waterfalls and everything?
Yeah, exactly. No waterfalls. This is really dangerous. This isn't dangerous. This is cool. So this is where Druid fits in. So Druid is a database. We finally got there. And what it does is it takes data off of message buses like Kafka or Pulsar, Kinesis. It also can read data from data lakes, so from S3, from Hadoop. There's also a new Spark connector, so if you're interested in that, please ping me because we are going to be doing some really cool things on the new Spark connector. So Druid will take the data from those different data sources and put it into a database, a columnar style database that has been designed for analytics, and specifically for interactive OLAP style analytics, where you don't need to know where all your queries are ahead of time, that your users can be more flexible and they can get to data that's fast and fresh.
How fast? And so we a lot of words you said there actually then overlap a lot with Trino, right? So that's why I wanted to, let's start making that distinction of what do you mean by fast?
What do I mean by fast? Well, we usually mean sub-second when we mean fast.
Yeah.
So Druid does support joins, and but it's definitely not its primary use case, because to us, joins would typically be too slow.
Yeah.
So yeah, we do support it for those side times that you need it, and I think that's where Trino comes in, is where you need to have that full function of joining data from various different data sources, and you're willing to wait maybe a couple of seconds.
Yeah.
For responses versus sub-second response times.
Yeah. And we'll dive. I think we have a lot of really cool use cases that are coming from Netflix that we'll talk about with Parth and Samarth here in a minute. But yeah, there are a lot of times where when you're looking at these systems and you're thinking, okay, I understand that these are both, handling as analytics use case, so they're going to be very fast in returning results to me and over a large set of data, right? That's the basic thing. But the question, the distinguishing factor is, one is that Druid's actually storing this data, and Druid also has its own, I guess, probably special types of like indexes and all sorts of fancy ways to make that sub-second latency happen. Right?
That's the magic.
That's the magic.
Druid sort of behind the scenes, yeah.
Exactly.
Well, also, I think it's worth pointing out that we have a Kafka connector, but obviously from Trino connecting to Kafka is great, but all you're seeing is the stream passing through. So as soon as the stream is gone, it's gone, right? So having a system like Druid where the data actually ends up landing unlocks that aspect of looking at more data in longer time periods beyond what's currently streaming, and then querying that with Trino works very nicely as well, right? You have yet another, in this case, super fast data source that interacts nicely with Kafka and streaming systems. So I think it's a great combination.
Yep. Yeah, it brings in something that we completely lack in Trino, and that real time element that basically if you're pulling out data and trying to do something like a window type query, something that's constantly updating in the query just kind of is something that persists. This is something that you can now do with Druid. Whereas in Trino, all we're really doing is pulling the data back in batches and specifically answering like a query in time. And it's just going to end at some point, versus Druid is a constantly ongoing query. And I think this is the common confusion by what our Kafka connector and what we do with any of these kind of streaming or pub sub type data stores. We're not actually, we're doing a batch process that runs on top of these systems. They're not these persistent queries. So I think that's a good distinguishing factor there, Manfred. Cool. So sorry for interrupting you, Rachel. I just wanted to, that was a perfect point for me to put in my little pitch of like, we constantly get this confusion. I remember starting out too, like I was constantly confused between the differences between like real-time systems versus batch systems. So carry on with telling us more about Druid.
I don't know how much more I have to talk about, actually. That was where, oh, right. Okay, so now let's talk about where Druid came from. So at the time that the people who wrote Druid were looking at this, it was about 10 years ago. We're getting close to our 10-year anniversary of the first piece of code. This was they worked for an ad tech company. So the first place where making sure that you could look at data that was straight off the wire and make decisions on it extremely quickly actually meant money. So ad tech was the first use case that Druid was used for. And what they did is they looked at time series databases and they said that these were good because they were low latency and they could do time-based queries, but they didn't scale very well. The other side of the equation, they could use search systems like Elasticsearch. I think we mentioned that, Elastic.
Yep.
And that's great for real-time ingestion. It had that Kafka piece done really well. It had the flexible schema thing done really well. But it wasn't good for analytics, and it's still not particularly good for analytics. It's great for searching,
Yep.
not great for those ad hoc style queries.
Yep.
What's good for ad hoc style queries? OLAP databases. And those had efficient storage and fast analytic queries, but it didn't have any streaming ability, and there was no flexibility in the schema. So what they said is, all right, let's take bits and pieces of all these three systems and let's smash them together in some sort of intelligent way. And that's how we create Druid. So I think that the next slide makes this. Yes.
Nice. Enter the Druid.
High performance, real-time analytics database for event-driven data.
So
and I always want to make sure database is up there, right? Because it's a database.
Yeah, absolutely. And that's another distinguishing factor for Trino versus Druid is like you guys actually store the data. We are yet a humble little query engine that sits on top of you. So one thing I wanted to be clear for anybody who's listening on the podcast, if you know Enter the Dragon, just picture that big front to that movie with Bruce Lee sitting on the front, and then instead of Enter the Dragon, it's Enter the Druid. I love that. Super hilarious. And well, these slides are in the show notes too, if you actually want to see the visual. So very fun stuff.
All right. I think that's it. Oh yeah, we have the obligatory architecture slide.
Yeah.
The takeaway from this, because not everybody can see the pictures, is that Druid was designed in a post-cloud world. So it was designed to work in a cloud environment as its default. So there is a very distinct separation of different types of processes. So you don't need to put a big, massive Hadoop style node to do very small amounts of processing, like would be a broker, for example. So yeah, go on.
I was going to say, for anybody who wants to kind of look, I pilled that one out because there's a lot to take in there, and I pulled out some of the definitions that are on the Druid website just to put into our show notes for easy and quick access. And it basically takes the architecture. There's a lot of different types of nodes that are being used in Druid for these different purposes. And so I basically just pulled out the definitions there if you want to check that out in the show notes.
So if you want to move over, sorry, you go, Rachel.
I was just going to say, if you want more information about it, you're welcome. People are welcome to find me, and I can definitely take them through it. But
cool.
There's lots of written
about it. So let me ask the obligatory architectural question that leads us over to Trino, which also leads us over to maybe Samarth and Path, who've been working on the Trino connector, and that is on that chart. I see that there is a broker nodes which receive the queries, which then talk to various other nodes, historicals, deep storage, and all that kind of stuff. And then I see the Kafka stream topics going in the real-time nodes. What does the Trino connector do? Who does he talk to? Those broker nodes, or like how does that work? Tell us more.
Well, I think that's the people who wrote it. Or
yeah. Do you want to take that one, Samarth?
Yeah. So the Trino connector, the Trino Druid connector, you can configure to talk to a broker or router, right? And so these nodes maintain a view of what data resides where. So the real-time data, can reside on what Druid calls middle managers, and the not so real-time data that has been handed off from these middle managers to historicals. And so the brokers maintain a view, and so as the query arrives, they know where they should direct so Druid, what essentially does, it does a fan out. And so the broker knows whether the query should be directed to middle managers or historicals or both, and merges those results back, gives it back to a Trino worker node, and then in turn, are returned to the user.
Cool.
Yeah.
Awesome. So there is only one of those brokers, or is there many? And then does Trino talk to only one, or does it talk to multiple?
So it can be configured. So like I said, you can talk to the router and the Druid router, and the Druid router in turn can have rules where it say, uh, maybe for a particular data source, I want to go to a dedicated broker, just like a random rule here. So it can talk to multiple brokers, and
Okay.
that's through the router. Or you can say, okay, I want to talk to one particular broker. Yeah.
But in general, yeah, there's going to be multiple brokers and routers in a cluster, and we usually say as a rule of thumb, one of them for every historical node that you have.
Okay. And then Trino can parallelize via the parallel query to talk to a whole bunch of them as well, basically.
No, so Trino, the connector can only talk to one.
Oh, okay. And then the parallelization happens underneath the hood in the Druid side. Oh, very cool.
When someone says it can only talk to one, what he means is for a given query, it is only issuing it to a host, one of the router. But even in the router or broker stack, you can have like 10 nodes running. So it's not like you are always talking to a single host, and if that host goes down, you're out of luck. It has multiple nodes behind it. But if you think about it from any other JDBC connector's perspective, you're talking to a MySQL database or you're talking to an Oracle database. This is very similar. There are not 100,000 splits. There's only one split, and it is just querying against that one single split. And then the majority of work is supposed to be done by Druid, because that's where it excels, when it has to do the whole aggregation by itself and not kind of return the raw results back to us.
That makes sense. So unless the query gets split up by the Trino planner into multiple queries that get issued separately, and then there's some aggregation or whatever processing happening on the Trino side, everything is done on the Druid side quite a lot.
Yeah, so this is like the ultimate like full push down, right? It's not trying to kind of as much as possible. You're basically just trying to get back a result set, and you're basically just saying take the entire query. I mean, is there any times where you have to kind of split things up, or you're not able to like do a push down, like kind of any use case outside of that where you're going to essentially like need to do some more work on the Trino side, or any need for parallelization? Is that use case ever come up?
Yeah, I think that is a use case. However, again, like, and I think this goes back to the notes that you have on why did we choose JDBC versus Druid's native query issuing capabilities. But going back to your question, there are a bunch of use cases where you may not be, like, if you're using a Presto function that doesn't even have an equivalent in Druid, there is no way to push that down to Druid, right? So in those cases, ideally, you would do what you said. We will basically just go to historicals and we would say, let's parallelize it, but let's have multiple splits and just pull raw data, and then Presto do the aggregation by applying the predicate or function or aggregate that is not available in Druid. However, that's not where Druid excels, and we don't view that, at least in the initial version, we didn't view that as like the thing that we should focus on. Primarily, we wanted to focus on the complete push down, and again, so far we are happy with the results that we have seen.
Cool.
So much you add?
Yeah, pretty much. I mean, the alternative is, instead of going to Druid historicals, Presto can directly query the deep storage, right? So Druid maintains its data on the historical nodes as well as, and there's a sort of there's the sort of the source of truth, which is in deep storage. So there are those various options. And like Parth was saying, these are, again, the various pros and cons of doing HTTP versus JDBC. We can get into those later, but yeah.
Cool. So why don't we hop down here into the PR of the week? We'll specifically pull up the initial work. I think I just kind of want to know some of the story. So Puneet Jaiwal was the initial person to kind of take the gambit of pulling together some sort of a plugin PR for this, right? So he did some of the early work, and then you kind of picked it up, right, Samarth? Is that kind of how it went?
Yeah, that's correct. Puneet, I think he used to work at Lyft
Okay.
during that time, and um, for whatever reasons, he stopped working on it, and then I just took over because we had an immediate use case where we wanted Trino connectivity with Druid, and that's how I ended up taking up this PR.
Cool. And can you go? Let's dive into kind of what that use case was, and kind of what you were initially trying to accomplish with the Druid connector.
Yeah. So the driving use case behind this was we wanted our our Tableau users, they have their data sets in Druid, but there's no way for them to be able to, at least not a nice way to be able to query that data in their Tableau dashboards. Um, the and so so this is, well, there's an alternative available. There's an Avatica driver available, but then at the end of the day, Tableau throws these kind of SQL statements that that Druid's implementation of the Avatica protocol cannot handle those SQL statements. So and we have lots of Tableau dashboards that can connect to our Presto clusters using the JDBC driver. So we know that that support is quite mature. In general, whatever SQL that Tableau throws, Presto can handle it fine. And so this is where we started. What if we were to connect our Presto clusters with Druid, and then let Presto handle all the complex SQL stuff, and see if if we can get good performance out of it. Druid supports all of these sub-second queries, and so if we could take those queries and push as much as possible down to Druid, we can have these Tableau dashboards, like super responsive dashboards. And keep in mind, we are talking about live connections here. So these are not Tableau extracts that user pull into whatever Tableau does. I think it's hypervisor or something like that. And these are live connections to the cluster, and so Druid and so you get all the goodness of live connection. There's freshness of data. You don't have to keep refreshing, and because it's Druid, you get billions or trillions of rows. You get excellent performance in the dashboards, which is so this is where this is sort of where the whole push came from, to be able to connect our Tableau with Druid.
So the kind of first push was more towards like less of a federated use case, but more like syntax layer mapping or something like that. Is that correct?
I would say so. Yes.
Okay.
Yeah. And there's also there were other use case where users wanted this capability of joining the data that resides in a warehouse with data that is in Druid tables, right? Or Druid data sources.
Yeah.
Druid does provide a limited join functionality through lookups and everything, but then it's a hassle when users have to configure Druid, or to add those lookups, make an extra copy from data that's already in data warehouse, and get it mapped to Druid, and so this is where we started. I mean, so
yet another thing that a reason why bringing this Druid connector to life was all the more pertinent. Cool. So then while you were kind of working on this, I think kind of in the background, or kind of like even before this, there was already work kind of coming down the pipeline that let me see, that Parth was working on. So Parth, do you want to tell us a little bit, and sorry, I didn't even relate how this work is related, but there's this basic change is not basic change. I shouldn't say, not a basic change. Basically, is what I was trying to say. This change was focused on enabling aggregation pushdown. This was just in the kind of core SPI changes that were needed to actually handle aggregation pushdown at all. Correct? This was just
So
okay.
basically the SPI changes, so we can expose it to the connector and then optimizer rules. So Presto's planner and optimizer could realize that these a connector is capable of handling the push down. And again, I want to make it explicit. This is complete push down, not partial push down. So this only handles the complete push down case, but these were changes needed so that any connector within Trino could actually one know what aggregation it needs to do, and then the optimizer could take that into account and change the plan so that it would not do any aggregation of its own. It would just treat the aggregation functions as like a direct projection, and it would know that the connector would handle the aggregation on its end.
Okay. Yeah. So
and there's been quite a bit of work on top of that. Like this has been definitely a very important PR. And since then, and also in the last couple of releases, we've done like there's more documentation about like limit push down, and we've done like the top end push down, which is like order by queries with limit, and so there's more and more of that happening, and it's very useful. And having it in the SPI, like you exposed it there, makes it possible for any connector to implement those for whatever functions they are, right? And that's obviously different, right? Like different connectors and different underlying data sources support different aggregate functions and different syntax natively. So it's on a per connector basis. So that's awesome that flowed into and came out of Druid to some degree. It's great.
Oh yeah. I mean, it's driven a lot of other things, including one of the other ones that we had to eventually add that capability to the client as well. So this one took it a bit further, and this was done by Piotr, enabling us to actually use this and on the front end as well. So
yeah. By the way,
Sorry.
Go ahead, Parth.
Yes, I think once we added the aggregate push down and top end push down, I think limit push down was there even before this. But once we added the aggregate push down and top end push down, Peter added it to the base JDBC, and then from there it just trickled down to I think MySQL, Postgres. So most direct databases, which is kind of equivalent to what Druid is. Like it is a complete data store and can handle aggregate function.
Mm-hmm.
I think it was done in all of those. And again, it's just one of the examples where you make a change in something that is very specific for us, but because it is applicable to any connector and Trino is good at it, it just
trickles.
It goes down to all of it. Everybody kind of gets benefited from it.
Yeah.
Yeah, and for our users that are interested in checking that out, in this last release, I documented this for the connector. So it like every connector now has a push down, like everyone that I know of anyway. There's probably some missing, so we should add some more. But it has a push down section where it links to more details about the different push downs that are supported and a list of functions that are being pushed down. So we obviously trying to expose that to users to make sure they can understand how to debug this and that kind of stuff. So
we just got a question, and so I thought question is, I thought the connector always did a full pushdown. Was adding aggregation pushdown for Druid a way to tell Trino that it had to do that, or is it possible to not use aggregation pushdown with Druid?
I don't know if I completely understand the question, but in the JDBC world, there is a flag. Let's say if you don't want your JDBC connectors to do aggregate pushdown, it's just a kind of config property or session property that you can set and say, I want to disable it, and it will disable it. It is complete pushdown. And what that means is when you issue a query like select count star from Postgres state like schema, Postgres dot schema dot some table, instead of earlier, before we did the pushdown, Trino would basically go and fetch all the rows from Postgres, and then we would do like a count aggregation on Trino side. But that's, again, like if you think about it, it's just not good because Postgres has indexing, has count, has all the metadata, and it can probably answer the query much faster rather than having to stream all the data back to Trino. Versus now that we have aggregate push down enabled, and let's say in Postgres we implement count star, Trino is telling the Postgres connector, hey, here is a function called count, and I want you, and the Postgres connector would say, oh, I can handle it. You don't have to worry about it. And the plan will change from like scan, aggregate, and then output to just scan and output. And in that case, the count is being done. So it only returns like one row back, and Postgres would answer it. So in most cases, I would say we have brought down the latencies from anywhere between minutes to tens of seconds down to a few seconds, less than 5 seconds. In case of Druid, what we have observed is we generally, even on billions of rows that we have aggregated over, we can generally respond back even with Presto within 2 to 3 seconds for a lot of queries where you are providing the right filters and aggregations and stuff like that.
Yeah, I think this this question, now that I kind of read through it one more time, is it kind of there's sometimes an assumption that like the being able to do push downs, certain types of push down queries is just automatically like something that can just happen. You just basically take it and pass it along, but there's not usually like a direct one-to-one mapping. A lot of times there are specific there are specific barriers. So for instance, like let's say you're dealing with something that has a slightly different syntax, or I'm not really sure the specifics of Druid. If I know you said that the syntax whenever you're dealing with Druid is not perfect ANSI SQL, so you may not be able to just take the aggregation and say, okay, spit it right back out and send it to Druid. I'm not sure if that was one of the
well, I think the best way to understand and explain this is probably for Ben is out of the box, and historically Trino was designed as a SQL query engine that queries, for starters, Hive data sources. So they don't have any of those functions. So the default behavior in Trino is to take care of just load the data from wherever it gets it from, which is often org or Parquet files or whatever, and then it does a lot of the function processing. So that's the default behavior. And the fact that some data sources, and obviously that's like many nowadays, especially with relational databases, do support for this, is sort of like a secondary consequence and an optimization method and an opportunity to optimize. And that's what the Druid connector added. But the default behavior is not to push down. It's to read the data and do everything on the Trino side.
Yeah. Well put. I think that makes a lot of sense. So hopefully that.
To answer your question, yes. Let's say there is a function on Trino side which is called count, and let's say count is not what Druid SQL support. It supports CNT or something else. That's where the connectors get, the SPI changes that we made comes in play.
Yeah.
It is connector's responsibility to kind of tell Trino that when Trino asks it, can you handle count? It has to kind of know that semantically the equivalent of count in that connector's realm is CNT, and it just has to tell Trino, yes, I can handle count. And then what it does behind the scene, what query it issues to the underlying data source is basically detached from Trino altogether. Trino doesn't know. It just says, okay, it can handle it, which means I don't have to do aggregate. I'm just gonna let a scan take care of it, and it just returns that. That's it.
Yeah, connector knows.
I don't know again if that was a question.
Yeah, no, I think we've definitely explained it pretty well now, and very good.
Ben chimed back in and said yes, he understands.
Cool.
So that makes sense.
Awesome. So so that was the kind of the awesome work that these guys have been working on recently, and I think there's one other bit of work that was kind of recently merged, which was a new set of so this was actually this is for top end. So would you want to tell us a little bit about some of these new rules that you've added recently to the SPI here, Parth, to handle top end as well?
Yeah, it's basically there were 3 sets we wanted to kind of go iteratively. So first and foremost was aggregate pushdown. Then there was the support for grouping sets, which is not very frequently used in our environment, but it is a it is a feature that a lot of other people use. And then the third one was top end, where you are just issuing like a order by with limit. And Druid supports all three of them. Trino supports all three SQL dialects, and bunch of JDBCs do support them. We just kind of divided the work in 3 different PRs, so it's easy to review. But right now, again, I think top end is something that Postgres, MySQL, all of those also handle that correctly right now. So this was just basically another iteration where we handle order by limit queries, and now even those get pushed down just like aggregate function down to all the way to the connector. And Trino doesn't do that work for them, makes it faster, just like aggregate function. There's not really much difference in terms of how you do it.
Gotcha. So we got two actual. So that one was I think what back in that one was back in February. It got merged in. Was it? It started in June. I thought it was merged like Feb, somewhere around there. Oh no, this is the wrong one. Was this one right? Yeah, top end. This was merged in on August 4th. Oh, I must have gotten that. Oh wait, this was okay. Yeah, it was merged in actually a while back. So I said recently. I lied. But we have a couple that are still on the horizon. We have so this is now aggregate pushdown for Druid. Can you explain now some of this work, as well as we have another optimizer rule to support the aggregate pushdown with grouping sets. So we'll start out with 4313 first.
Yeah, that's just me being not focusing on this, because most of the time what happens is we develop the feature internally, we work with it, and then whenever I or somebody else in the team gets time, we kind of take that and try and post it into OSS. We run on a very different versions, and we have too many internal patches, so it's generally a lot of efforts to kind of port that to OSS. But this is, I think I opened this almost, I don't know, a year ago. I just need to address some comments, and then hopefully it gets merged in, and then everybody could basically leverage the same functionality on Druid. I'm trying to do this before our meetup, so that we can actually claim that anybody can use it rather than them having to do the merge operation themselves. But yeah, this would basically allow people to do what we are talking about, the use case of pushing down the complete query at Druid, and that we internally again have this and a few other stuff to make the connection work, and we can talk about that. But the PR is adding this, like just like we did for MySQL Postgres, just adding the actual mapping of the aggregate functions that Druid can handle. It has to kind of expose that information to Trino.
Mm-hmm.
And this PR kind of does that. It basically exposes that, oh, I can handle count or whatever else.
So this is like the final step in all of this work that you all have been doing. It's like the I don't know, the final countdown or something.
Yes, that's what it is. Basically, once we have this in, then when you issue a query, it would to Druid, it would do a complete push down as long. And again, there are some caveats there, which is you have to use the functions that Druid connector has exposed. Like if we don't handle count distinct right now. So if you did a count distinct, that would become like a scan query, because Druid would say, a Druid connector would say, I don't know how to handle it. And then we will just scan all that data back.
Got it.
Right. So it's just it's just the final PR that would allow people to use the Druid connector with complete pushdown. That's why we did all the other work. We just got all the other work done. We merged this in our internal version. We got done with our proof of concept and our users started using it.
Yeah.
I just never got back and updated
it's
the PR. So
it's funny how the hardest PR is to finish is the last one, like, right? That gets you, like, it's the easiest one, but yet it's just like the one that gets you right over the finish line, and you're like, oh, I'll get to that, and then it
Exactly. I'm really bad with this. I have a bunch of these that have happened. So I think at this point it's even harder for me to ask like Peter or David to review, because I know they'll be like, you won't come back and address my comment for another year. So I don't know if I want to review it. So
yeah.
But yeah, I'm hoping to get it out. Let's see if I actually, be honest this time and do it by end of this week or not.
Here's what we'll do. When we get back to face again, we'll just hang out at a conference in a room for about an hour and just knock it out.
I'm up for it, but let's hope it doesn't get to that.
Just messing. And then yeah, so then the final one is pulling in. So now that we have all these fancy things, we can actually start adding even more aggregations. So you would be adding in the next one, which would be grouping sets.
Yes, again, that's just another optimizer rule, because if you right now you can only say select star from table group by A, but if you were to say grouping set and then let's say country and city, then those things won't be pushed down. It's just an optimizer rule that needs to get in so that it can expose that, because Druid supports it as well. Druid supports the grouping set functionality as well. So it's and bunch of again databases that they support it as well, but this is still relatively niche, I would say. Like grouping sets are not very commonly used as far as our environment is concerned, so I don't know how commonly it is used outside, but it's just one more functionality that I think would make it easier for people to use the overall connectors across the board.
Awesome.
Yeah.
Cool. Anybody else have any questions before we hop on over to the oh man, I went on the wrong page. Till we hop over to the demo of the week. All right, let me do this real fast. This is like going to be a super simple demo, just to kind of, this is actually a way to force myself to start working on this getting started repo that I've been working on. So if I have one of these that I do, I'll basically have a nice simple getting started. So there's nothing like mind blowing with this demo, but with it, we let me see if I can pull up the code here. With it, we can basically just showcase bringing up a quick Druid instance, and this, as we had kind of shown before, is going to involve involves Zookeeper and Postgres backing that, and then we have coordinator, router, historical, middle manager, and broker node, and basically, let's pull this to the front. The code, and this is all going to be a part of the all included in links in the show notes. But in the code, what we basically have is a little directory that's going to contain a Docker Compose file to pull all these up, and including your Trino instance. And Trino will basically have the correct configurations. Let me pull up that configuration now. Very simple in this case. We're just going to basically delineate the connector name to be the Druid connector, and then we're using the Avatica JDBC URL there. So it just points to the broker in this instance. So once we've configured that, you will run Docker Compose up, and this will bring up this little instance here. And once Druid is up and running, you can actually go to their console. And I gotta say, like, coming into this console, I was like really jealous. There's a lot of super nice things that you all have going on here. Let me make sure I don't have. Let me pull our little setup here. So yeah. You basically have all the keys. Like usually I have to go like fish out for some other data, or I can, if I had insert. Currently Druid doesn't support inserts, so what I typically do is I'll pull out from our TPC or TPCDS data set, and I'll load it into the whatever data store we're going into. But here I didn't really need to, because I can literally just click on load data, and they have a couple things you can do. You can either like point to a REST service, or pull on local dist, or paste random data. All sorts of fun little things you can do here, all from the UI. So I just pulled into this little example data set up here, and they just have this Wikipedia data set. So I just literally loaded the example, and then I closed my eyes and I started clicking next. So we'll keep doing that next. Now, I'm not going to explain this just because I don't want to take all the time, but there's a lot of options that you have here to customize and the data set and customize the schema based on what you're pulling in. But if you're just wanting to kind of, validate that this works and start playing with data, you can literally just go across. This creates this ultimate specification that tells Druid, how to load in this data set, what the schema is, and all this stuff. And because this is the example data set, it works. But if you're pulling in your own data set, you might have to adjust with some custom knobs and stuff like that to make sure the schema works. And once you do that, you can submit, and it will take you into the ingestion page where it's actually running this little job that is going to pull the data in, and it's running. And you can refresh and wait till it's not running anymore, till hopefully it says it's complete. And I might have actually, oh, funny. Yeah, I think if I refresh too much, I end up killing the broker. I did that last time. So let me just pull the broker back up. It's because we're literally running this on a really small Docker container. So no fault to Druid. It's more of my... We're back up. We're back up. All right. Hold on now. Last time I did this and it worked. If we continue from previous spec.
It's because it's a live demo, Brian.
I know.
That's how you know it's live.
It is very live. I just needed to do this just for the fact that you all knew that I was really doing this. And now you know it was really, really done. Okay, so let's see if... Okay, I'm actually going to hold off on refreshing because I don't want to kill the broker again. Oh no, this time historical died. Again, I need to get a bigger... It's just really unfortunate because I'm running OBS and I'm running Docker, so I can't really hog up too much of the memory here to actually run this.
There's always a reason to buy a bigger machine, isn't there?
Always.
One more.
I'll let our CEO know. Oh, we got another 502. Well, let's see. I'll pull this up one more time. One time I actually killed it, and then it actually ended up loading the data successfully once I pulled the broker back up. So I'm hoping that that will happen. See if there's any data sources yet. We'll look at see if there's a data source once the broker's responding again. And if not, we can move on. Oh, hey, we had lots of success actually. There we go, fully available.
So what's happening behind the scenes, Brian, is that the data is getting loaded to deep storage.
Yeah.
And so the segments are created. So it takes the data from the Wikipedia segment, it uses that ingestion spec to create these segment files. The segment files get stored onto deep storage. So that becomes your sort of your backup, or it becomes the store for all of your data. And then what Druid does is it, based on load rules, it decides which data gets loaded up into the historicals, which is available for querying.
Cool.
So this allows for either roll data off or tier data based on its age and how fast of a tier you want it on. So it always takes a second when you load up a new data source, because it's doing more than just throwing it into a table, which a lot of relational databases will just throw it into a table and even put it into memory, so it's immediately available. But Druid is actually making it ready for real life environment. Got it.
That's pretty amazing.
So, yeah, no, it's that's one of the things too, is you can deal with actually both more of a you can handle somewhat of a batch load and then also have it be real time as well. Okay, so we've refreshed this. I've already pulled this down, so this actually is not as entertaining because this was already loaded up from the previous time before I deleted the data. But if we show the create table statement, even though we didn't create the table, we're still able to pull this out and see all the different fields that came from this. And ultimately, we can get the data back And that's kind of the hello world of this that now is one of our getting started tutorials that you can all set up. So very simple demo today, nothing mind blowing, but I mainly I think was more just showing off the Druid API or Druid Web UI there. So very, very cool. The last little bit, let me go ahead and adjust real fast. One more little thing. I'm just gonna pop you all over here. Okay, last thing, we kind of started talking about it a little bit, and I'd like to just dive in one more time to kind of, really delineate what is the native JSON kind of call versus the HTTP call. When this question gets asked a couple times, has been asked a couple times since the Druid connector came on the scene, and I would like to I in the show notes I put smart take and parse take that they put out onto Slack to kind of really talk about this. But I kind of wanted to understand, and maybe this could be a question for Rachel, Samarth, or Parth, of what are the differences between these two, and who are you actually talking to? I know we kind of touched on it earlier, but I'd like to kind of jump right back into that to kind of answer this question.
Yeah. So in case of JDBC, right, you're talking to a router or a broker. They can handle they have basically endpoints exposed that can handle SQL queries, which in turn these nodes then compile the SQL query into Druid's native JSON query behind the scenes, and then farm it off for execution, doing the final merging and returning results back. So that's the option we sort of went with. There are a few reasons why we decided going the JDBC route. To me, the most important was a couple of things that were important. The Druid's SQL support has been improving, and it hasn't been officially recognized, but then this generally is the general idea that's floating around is that going forward, SQL is going to be the de facto for Druid, for getting data out of Druid, and with native JSON being for specialized use cases. Then secondly, the reason we decided doing the SQL route makes sense is, a lot of times users execute queries that may not be, so if you were to craft a native JSON query, a lot of times those queries may not be the optimal way of getting data out of Druid. Druid has all of these now planner changes implemented where it knows what is the most optimal way of executing a particular query. So, and all of these optimizations are in place in the SQL land. So we thought, if we were to provide all of these JDBC SQL-based functionality on the Presto Druid connector, users won't have to worry about whether they're executing a query that is optimal for Druid, right? So that's the reason why we said, let's go the JDBC SQL route. And there were some concerns about, there is some time it takes for Druid to parse a SQL query to a native JSON query, which is what it does always. But then we thought, that bottleneck is not substantial. We in our experience, it maybe take a few milliseconds, which was good enough for a use case. And so that's the whole the reasoning that or the thought process that we went through when we decided we should go through the JDBC route.
So other than parsing, does it really give you much benefit to it's in general, you're seeing that it's more beneficial to do the full push down rather than this partial aggregate and bring things back onto Trino, right? Is there ever what would be one of the or any case that you've heard of anybody bring up or maybe at Netflix where it is more beneficial to just basically scan the data and then do something maybe closer to home?
So Druid generally is, so there are two ways to get data out of Druid, right? One is you hit the broker and the broker will do the fan out to the historical nodes. The other is these historical nodes, they can themselves handle queries. Um, so, these historical nodes cannot handle SQL queries. They only handle native JSON-based queries.
Yeah.
So, if we were to, issue this scan style of query to Druid and to the broker, what the broker would essentially do is call each historical, pull all of data out, merge all of the data in broker. As I mean, it would stream and merge the data and send it back to whoever is asking for it. Druid generally is not built for it. It's just going to put a lot of load on the cluster. Uh, the other alternative is if the callers can directly make these queries to the historical nodes. For that, they would need to know what data resides on what historical node there. So they would need to know for this particular data source, for this particular time interval, this historical node has the data. So they would have to maintain all of that logic that the Druid broker maintains. They would have to have some kind of that mapping within their layer or within their app, so that they can directly issue queries to the historicals. So we don't have a use case for that, but I can see where it might be beneficial. Um, for example, if you were to issue a group by query, and the group by key space is really, really large, if we were to issue such kind of queries from broker to historicals, then when broker does the merging, because the key space is so large, broker would just, let's say, fail with an out of memory, right? The alternative is for something like Trino, where each Trino worker node would know what splits it has to hit. So there would be like n splits corresponding to n historical nodes. And Trino has this more sophisticated merging, right, where it can form like a tree structure and say, okay, I would do the first level, my first level query would be to just go issue queries to the historical nodes. Then I would do like a tree level merge so that none of my so none of my worker nodes fail out of memory.
Mm-hmm.
Trino has a much more sophisticated algorithm.
Yep, that makes sense.
Yeah.
Cool.
So yeah,
Sorry.
and if
Go ahead,
path is something
go
out
ahead,
there.
go ahead.
Yeah. So that's those are some use cases where this might help. In going directly to historicals via HTTP versus going to broker using JDBC or SQL route.
Okay.
Yeah.
Parth, did you have something you wanted to add on that?
Yeah. So the major right now, I would say the major reason for us doing it is, if you want to do what Samar just said, and again there is room for that, you will have to implement partial push down handling rather than complete push down handling, which is what we did.
Mm-hmm.
And that is a whole level of complexity, which, like, I would say it is at least, if not 2x, 5x, 10x more difficult to change the optimizer and the planner and all of that, because like there are just mathematically I can probably do min of min, I can't do count of count, right? So how do you handle that, because there are semantical differences there. So the first problem is that when you want to go to historicals or deep storage, first you have to understand there are three options. Option one, you go and ask Druid to do what it's best at, which is it can farm out, it can do merge, and it can give you results back within milliseconds. Or you can go to historicals, but you need to know the state, and you need to manage partial push down on your end. Or you can go to deep storage. Again, you need to kind of know the state, and you need to do partial push down. For us, it was very easy to kind of see that the fastest way and the majority of use cases that we were looking at, it makes sense to go to the first route, because that's where Druid excels anyways.
Yeah.
The second place where it will be useful is right now, if you think about a query which is like select count from a table, that works. If you have a query which is select count from where column equal to X, now Druid does predicate push down as well, which means that it can handle that as well. But if you have a query which is select star from table where some presto function which does not have an equivalent in Druid, there is no way for us to push the aggregate down as well, because you can't apply the aggregate and then apply the function, right? Because that won't give you the correct results. So in that case, we have no option but to stream the results back from the broker, given the approach we have taken right now. So in those cases, it makes sense to go to historical get the results back, and then give you the let Trino apply the function, the filter push down, and then do the aggregation on top of it. And we, again, I think this is something that we had to handle internally, because a lot of times, if you have like case when, coalesce, all of those are not currently handled in Trino. Like if you have anything a little bit more complex, which is what Tableau will do, then it won't be pushed down. So what we had to do internally is handle all of those kind of push down too. So we now have function push down, cast push down, coalesce push down, case when push down. Like there are a bunch of things that we handle again, but which we haven't really had the time to go and publish a PR for. But though that's where we knew that Trino is going towards, that we as a community, there is a good push to kind of have all those features also being pushed down. And once that is available, there is literally very little reason to go the historical route or the deep storage route, because essentially what you want is the one case where the broker is a single node trying to do all the merge. That's where it'll be a problem. But and I don't think people are looking for that use case as much. At least I haven't seen it in my
and I was going to ask, is there any way to address that like easily in Druid, or is it just vertical scale, like you just start throwing more memory at your brokers? Or
yeah, it's a vertical scale.
Okay. So hopefully you're not running those all the time, and if you are, then it's just going to cost you more RAM.
Yeah.
Sounds good. That makes sense.
I think at some point we will handle it. We will have to handle it. And to us, it was also like, as I said, it was fastest way out, addresses majority of use case, and it's an implementation detail.
Yeah.
You could change the connector to use Druid native JSON at any point, and the users won't even, know the difference. It will be something that they could probably control, or we could control it with, depending on the shape of the query. So for us, as I said, if it addresses 95% of use cases, it's better to build that rather than trying to focus on the 5%. So
that makes sense, especially keeping things like in the code maintainable is yet another small argument, at least while it needs to be.
Yeah. And again, in this case, we were able to just use Presto's base JDBC for the most part, which, you basically gets to reuse a lot of code.
Yeah.
It generates the SQL and all of it, rather than having to kind of do a lot of those work. The state management itself would be a lot of work, I would say, given that we'll have to figure out which historical to hit, right? So to us, again, it was more like a simple choice because we were targeting a use case which is more prevalent anyways.
Cool. Anything more you'd like to add to that, Smarth, before we, or Rachel, before we hop off? Nope. All right. Well, thank you very much for joining us today. I think I've learned a lot about Druid today, and understanding specifically some of the intricacies that went around some of the development, and really hoping that everybody else was taking away as much as I did. So just wanted to say music for the show is as Mega Man 6 gameplay album by Krzysztof Slawikowski. You all have a great rest of your day, and we'll see you all in 2 weeks.